2.2 is due today. Homework? Any questions?
2.3 is also due today. No?
I mean, no, I didn't.
Oh, okay.
I changed it because we didn't finish 2.3. I extended it. When I changed the dates, Wiley Plus doesn't send you guys an email?
Nope. We get emails inside of Wiley Plus, but not emails to us.
Yeah.
So you have to
So when you
log
log
in.
in, it pops up like.
It doesn't even pop up. You have to check your messages.
Oh.
Notification.
Oh,
There's,
okay.
yeah.
Well, there's a new email to check now. Wiley Plus email. Okay. It actually emails me, so I don't know.
Because you're the professor.
No. It emails me as if I were a student. It emails me and tells me your instructor updated the assignment.
But
Like I'm the
Well,
instructor.
maybe you
yeah,
have
but
it
you're the
set up
instructor too,
backwards.
so it doesn't work.
Maybe you have it set up to email the
Well,
instructor.
you can change the
instead of
settings.
students.
You can
I don't know. I'll check. All right.
Mm.
Anyway, 2.2 questions. Any problems you tried that were getting you in trouble? No.
How about all of them?
Well, I don't know. Let's continue with 2.3 then. We are going to cover the last thing in this chapter we want to look at is mixture problems. Some preliminaries. Things like units will be important in this section.
No blocking.
Okay, so let's start talking about some of these things that you will need to know. Concentration. What is concentration? Focus. No. Like in the chemistry sense, what is concentration?
The amount of something in all the substance. It's
Mass over volume. The amount over per unit volume. Amount of substance per unit volume. Amount over volume, basically, right? That's something you're going to need to know. Amount can be given in mass or it can be given in weight, but this is the idea, right? When you can tell me how much stuff is contained in a certain unit space, you are telling me the concentration of that thing. It's very similar to density, except it's usually used when something is dissolved into another. So that's something you need to know. So for example, example of units like this would be like grams per gallon, or pounds per liter, things like of that nature, right? So if you're reading a question and you see, oh, it's 5 grams per gallon, you should realize that they're telling you about concentration, right? It's going to be important for you to know what that is. Something else for you to know what it is. Let's talk about the amount. Right? So obviously this has two things, and you need to know what they are. There is some variation to this, but basically in this course, this is how you're going to tell when you're being told the amount of something. And the common units would be units usually used to measure solids. Right? So, if you go to the supermarket and you want to buy sugar, do you buy a gallon of sugar? No, you buy a pound of sugar, right? Sugar is a solid, it's usually given in units of pounds. So things like pounds, right? Or you can say I bought a kilogram of sugar, or a gram of sugar, right? Grams, kilograms, etc., right? Things to measure solid objects. A pound of salt, right? A kilogram of salt, 3 grams of salt, right? You wouldn't say I bought a gallon of salt, right? Which brings us to volume. The common units here, units usually used to measure liquids. Right? For example, gallons, liters. If you're in chemistry class, things like CMQ, right? I bought a gallon of milk. You never say I bought a pound of milk, right? So that will sort of identify you, because basically you're going to be doing a lot of word problems, so they're going to be saying all this stuff. You need to know what is what, right? So they say something is something grams per gallon. You need to know, oh, they're telling me concentration. They say, oh, 5 pounds of this is that. Oh, they're telling me the amount, right? Oh, this is this many gallons. Oh, they're telling me a volume, right? You need to be able to identify, right? So these are usually how you identify them. So that you need to be aware of. Another preliminary you need to be aware of is the rate in, rate out idea. Right? So to measure how something changes if some stuff is, this red stuff, very vague, but I'll make it clear soon, is coming in and other stuff going out. Is by, how do you express this idea in terms of rate in, rate out?
Well, in the swimming pool problem, we did the amount of dye divided by how many gallons of water were in it.
It's not a division.
Is the rate in minus the rate out?
Rate in minus rate out. Right? So for example, if I have a tank and I'm pouring in 3 gallons of water and at the same time 2 gallons are leaking out, how is the water in the tank changing?
By a gallon.
It's increasing by 1 gallon, right? You just take the 3 minus the 2, right? You subtract what's leaving, add what's coming in, is basically the idea. Rate in minus rate out. Right? That's another important idea for you to know. What other preliminaries do we need? So rate in and rate out, concentration, volume, amount of substance. Okay. So now, mixer problems. The usual letter we use here is Q, but you can use anything really. Let Q be the amount of substance. At T. So basically, we have a tank, we're pouring stuff into it, stuff is leaking out, right? So you have some sort of solution in, and you have mixer coming out. Right? Now, current amount of substance is given by Q of T. Okay. Now when I say amount, what am I talking about?
Liters? I don't know. Weight?
Whatever is like dissolved in this, right? You guys remember the chemistry? Did you guys ever take chemistry? Right, this is like a solution, it's like a mixture. So like you can have salt and you can have water, and I put the salt in the water, it's a mixture, right? The salt would be the amount of the substance I'm talking about, right? So basically like, what?
Concentration?
No, concentration is amount divided by volume, right? I'm only talking about amount, right? So it means I'm talking about what's called the solute, if you do chemistry, that's what it's called. The thing that's dissolved in the other thing. The mixture is, from chemistry, the solution. So I need to figure out how much is coming in versus how much is going out, and we sort of want to describe this with a differential equation. Right? So example, suppose we have a salt solution. Salt dissolved in water. We can make Q of T the amount of salt at time T. The mixture is a salt solution. Now, what can come in can vary, and we're going to talk about that, but that's basically like a rough example of what's going on. Or in the case of your homework from chapter 1, the dye was the amount of the thing, right? So we have this pool, it had fresh water in it, but it also had this contaminant, it had dye in it, right? And you want to measure how that contaminant behaves under a filtration process, right? It's really a mixture problem. So, if we wanted to describe this by a differential equation, how would I describe how the amount of substance is changing, its rate? What is the rate of change of the amount of the substance? Rate in minus rate out. Now I gave you this hint for chapter 1, but I want to make it more specific this time. How do you really measure rate in?
It depends on what rate you're looking at.
Let me give you an example. Suppose I have 3 gallons per minute coming in. I have 2 gallons per minute going out. And suppose this has a concentration of, you know what, I have half a pound per gallon of contaminant.
So your rate is going to be pounds per minute.
Right, the rate I would be looking at would be pounds per minute in that example. How would I actually get that?
By multiplying how much of the contaminant
Right,
you have.
you can take what you learned from physics and just work with the units, right? If you take pounds per gallon, multiply by gallons per minute, the result is pounds per minute, right? So what did you actually do? You took the concentration and you multiplied it by the rate of flow that it's coming in, right? So this rate in can really be thought of as the concentration in times the rate of flow in minus, what do you think rate out is? Well, pretty much the same thing, right? The concentration out times the rate of flow out. So to construct this setup, that's what we're going to be doing. And I can, just to make it nicer to write down, I'll probably call this C in and call this R in minus C out, R out. Now it turns out this, and this will usually be given to you, right? Just right off the bat. They'll tell you this is how much is coming in, this is the concentration, and this is how much is flowing out, right? The thing that is not always known, well, that's almost impossible to know basically, is the C out. So we have to sort of tweak this formula to deal with that quantity, right? So assume we're told this, so we know C in, R in, minus C out. How can I actually write down what C out is?
Concentration of the whole thing.
Right, you need the concentration of the mixture, right? So what do we need to say about the mixture? The amount of substance per unit volume, right? What is the amount of substance in the mixture? It's just Q. Right? we can still make that more specific. How do you think I would measure the volume? Right? Q is the guy that I want to solve for. This I'm told, this I'm told, this I'm told. Usually they'll be constants. What about the volume? How can I represent that quantity? What? The original volume?
However much can come out.
The initial volume plus the rate going in minus the rate going
No, at the flow, it's good.
in, times time.
You don't
Yes, they said
understand.
V0 plus R in minus R out times T. Right? Which is what those two sort of said together. Does this make sense? Why do you think that makes sense? You want to do an example? Well, how about we go back to the same example? 3 gallons coming in, 2 gallons coming out. Let's say in the beginning, the initial volume was 100 gallons. Right? How can I measure the volume here? Right? So it means I start with 100, but it's not staying at 100, obviously, right? I have 3 coming in and 2 going out. So what function would measure the volume per minute?
That thing right there.
Right, but I want you to reason through without knowing the formula. So in case you're on a test, you forget the formula, you can sort of just think about something and figure it out.
Flowing minus flow.
Right, so you know that 3 is coming in, 2 is going out, so how's the volume changing?
Per minute, so
Per minute is changing by how much?
1. Increasing by
Positive 1, or it's increasing by 1. So I know I'm adding 1 unit per minute, right? Times T,
Yeah.
right? So how did I get this 1? Well, I took the rate in minus the rate out, right? And 100 plus T would be the volume, right? After every minute, it increases, right? So that's how you get this formula. Therefore, for these mixer problems, this will be the differential equation that models it.
But the volume won't be always changing with time.
R in minus R out times T times R out. Where Q equals the amount of substance contaminant that we're looking at. C in is the concentration in, C out is the concentration out. Well, I actually never wrote that in this formula. R in, rate of flow in. R out, rate of flow out. V0 initial volume. And obviously Q prime is the rate of change of Q, right? So it means that any mixer problem, I can represent it by this differential equation, right? Now the hard part is, well, hard, if you don't remember what I was telling you before, is figuring out what numbers to plug in all these various places. Yes?
So it would be rate, flow out minus flow in times T. Is that?
No, in the example, what do? If 3 was coming in, 2 is going out, we know we want to go plus 1, right? You'd have 3 minus 2. Right? Yeah?
So you can always change that, or no? It's always in and then out. It's always in minus out.
Yes.
Okay.
Right? Because the out is decreasing from the what's there. In is increasing. So this one's positive, that one's negative. So basically for any mixer problem, like the ones you'll be asked on your final, that's the guy that you're going to use to solve them. Now all that's left is to read the problem. and figure out what these pieces are. By the way, what kind of differential equation is this?
It's separable.
No, it's first order linear.
God damn, I was on the top of my tongue. I should have said it.
Yeah.
Plus 5.4 next quiz.
Right, yeah.
Like you told Diane, right? Always, like, what's the deal? Like, you two talk about me outside of class?
I went to his other class and caught him in class. He was like, tell me the general form of first order linear equation.
I was like, that came out of nowhere. I was like, what the hell is this?
Yeah. So, I mean, some professors joke about, if I come to your house at 4 a.m. and wake you up and ask you this, you should know. Yeah, I'll actually do that. I will find you on campus and ask you something. You better.
On campus, not my home. My home, that's my plan.
Well, if you get it wrong too many times, I might track you down in Chinatown.
You're gonna track me down?
Track you down in Chinatown when you're building that illegal wall. Start asking you to
You know those walls and doors go for your protection, not mine.
Right. The illegal wall is for my protection. Yeah. Okay. All right. So a couple classes ago, I gave you guys this. We're going to go through this. So we're going to practice on how to read these word problems and set up the differential equation and solve them. Okay? So this is the general form of a first order linear equation, because this doesn't have to have a q in it, so it doesn't have to be separable. It's only separable if this happens to be 0, then it's separable. Okay? All right, so we'll go to the first thing and we're going to answer question 1.
Professor, I have a question about that. What if, in a situation where the rate is lower than,
T is time.
in
Yeah?
a situation where the rate in is smaller than the rate out, can
Then
you-
your overall volume will be decreasing, right? So let's say 3 is coming out and 2 is going in, then your volume will actually be this. It decreases by 1 per unit time. Right, because you'd have the 2 minus 3, which gives you the minus 1. It still works. All right, so consider a tank used in a certain hydrodynamic experiments. After one experiment, the tank contains 200 liters of dye solution with a concentration of 1 gram per liter. To prepare for the next experiment, the tank is to be rinsed with fresh water flowing in at a rate of 2 liters per minute. The well-stirred solution flowing out at the same rate. Find the time that will elapse before the concentration of the dye in the tank reaches 1% of its original value. Okay, let's go. What do we do?
Identify the
So we know that Q prime, so first we identify our variable, let Q be the amount of dye after T, are we in minutes? T minutes. In this case, what is C in, what is R in, what is R out? I'm going to just write down the formula and then we plug them in. All right, so that's going to be our formula because it's a mixture problem. What's the concentration in?
So it runs to 1 gram per liter.
No. Concentration coming in.
Zero. Zero is fresh water.
Okay, now that's just getting ridiculous.
Is zero.
What is coming in?
200.
Fresh water.
Fresh water is coming in. What's the concentration of salt in fresh water? 0. It was 0. It was 2. What's your name again? No, this is I1. 0 is coming
so
in.
wrong.
What? Fresh water is coming in. There is no dye in the fresh water. So the concentration coming in is 0. Okay, now we move on. This is going to be Q over, what's the initial volume?
200.
right? We have a 200 liter of dye solution, so 200 is the initial volume. How is it changing?
What do you mean?
What's the rate in?
2
Two?
per minute.
What's the rate out? It's also 2, right? Rate in and rate out is the same, which means the volume is going to stay the same, right? It's going to change by 0. So our formula still works in that situation. And what's the rate out?
2 liters per minute.
2 liters per minute, right? And you can write in the units if you forget.
So now 0 is there, it's separable.
That is correct. That would be my next question. What kind of equation is this? It's separable, right? We can cancel the 2 into the 200 to get 100. So for this situation, that is the differential equation that will model it, right? And so now we need to solve this differential equation. By the way, what is the initial condition? When I say Q of 0, what am I saying? The amount at time 0. What is the amount of dye at time 0?
200 liters.
Liters is not an amount. Remember, liters is a volume.
200
200
grams.
liters is not the amount.
200 grams.
200 grams? How do you know it's 200 grams?
Yeah, the cost.
1 gram over a
You had
liter.
200 liters and you have 1 gram for every liter. So 200 grams is the initial amount. Right? So this is why the units is important, and understanding what these things are is important, to be able to pick out the right numbers, right? Some people are telling me 200 over here. No, the 200 was the initial condition. Okay, so that is the differential equation with an initial condition that deals with our situation. So how do we solve this?
We want you right on the board.
Tell me, what do we do?
Separate
Bring the Q's
it.
on one side.
They're separable, right? So we have dq dt equals minus q over 100, so
So Q dq equals
No.
negative
DQ
1 over Q.
dq over q equals minus 1 over 100 dt, right? So
and
integrate both
integrate
sides.
ln of Q equals. Now we plug in the initial condition.
Right, so q of 0 equals 200 means e at q equals 200 e to the minus t over 100. So I plug in 0 here and 200 here, I get c equals 200. So this is the equation that tells me the amount of dye at any given time. Now I can start to answer the question. At what time will the concentration of the dye reach 1% of its original value? How do we figure that out? Right, we want Q to equal 1% of 200, which was the original value, right? Percent means divide by 100 is just 200 over 100. So we want Q is equal to 2 grams, right? How do I figure out the time when Q is equal to 2 grams?
So Q equals 2 grams.
Plug in Q equals 2 grams, right?
And solve for Q.
And then at that point we solve for T. So this is minus 1 over 100 equals e to the minus t over 100. This means minus ln 100 equals minus t over 100. This means t is equal to whatever that is in minutes. Yes.
What is that 200? 1% of 200, what's the 200?
200 was the amount I had in the beginning, right? That was the Q of 0.
But isn't it saying that it should be 1% of the concentration.
No.
Oh, it's original.
But what? Find the time that will elapse before the concentration of dye in the tank reaches 1% of the original value.
It doesn't matter because the flow in and flow out is the same. Oh, it says the original values. Yeah, okay.
It'll work out. Right, so we can say when the concentration reaches 1% of its original value, the concentration was 1 gram per liter. Right, so 1% of that would be 0.01 grams per liter. And then if you put 0.01 times 200, you still get back the 2. So it'll work out the same. Okay, that was the first one. Turn up to the next page. We're going to do another one just to try to see if we can get to read these problems and sort of pick out the information that we need and put it in the right place. So as you can see, this is from an old final exam, so these problems will come up. They do come up, and they're guaranteed to come up. All right, so let's start. A tank with a capacity of 100 gallons initially contains 50 gallons of water with 10 pounds of salt in solution. Fresh water enters at a rate of 2 gallons per minute. The well-stirred mixture is pumped out at a rate of 1 gallon per minute. Compute the amount of salt in pounds in the tank at the first moment when the tank is filled. So I have a situation where I have a 100-gallon tank, but it's only filled halfway with 50 gallons. I'm pouring in 2 gallons per minute, only 1 gallon per minute is leaving, which means the water is going to rise, right? Eventually the tank will be full, and I want to know how much salt is in the tank at that point, right? So that's the situation. So this is fall 2011. This is problem 5. That Q equals the amount of salt. It's a mixer problem, so it's definitely going to be C in R in minus Q over V0 plus R in minus R out T times R out. What's the concentration coming in? 0. Fresh water is coming in, there is no salt. What's the initial volume? 50 gallons is in the beginning. Rate in is what? It's flowing in at 2 gallons per minute. Rate out?
1 gallon.
1 gallon per minute times T. What's the rate out? Well, 1 gallon per minute. Right? Yes?
Why the rate in is 0? It says the
Concentration
it's gonna grams per liter.
Fresh water is coming in. Right? The second sentence says fresh water enters.
Is it? No.
Are you looking at? Oh, it's this on the back. The next page. It's fall 2011, problem 5. Right? Fresh water is coming in, which means the amount of salt per unit volume is 0 coming in. Right? And so now we can simplify this. This means Q prime is equal to Q over minus Q over 50 plus T. How do we solve that differential equation? What kind of equation is it? Separable.
Is it?
So fun, you got jokes.
This is math class, come on. It's boring, you know, might as well just make jokes all day.
Right, so that's what you separate it. You integrate both sides. So this means ln Q equals, what's the integral of that?
Negative 50.
So this means Q is equal to what?
-50.
What? Q is equal to what?
50 plus T. Negative 50.
Oh, T plus
C.
Oh, gotta go by the count too.
Yeah. So if I put E here, what happens?
Yes.
1 over 50 plus T.
1 over 50.
This one becomes 1 over 50 plus T. What about that plus C? What does that mean?
C.
Wait.
It multiplies by a constant, right?
So it's still constant.
Right, so it's C over 50 plus T. And since, what is Q of 0?
10 pounds. It's given, right?
Yes, it's given. I just want to make sure you guys know how to read it. So Q of 0 is 10. What does that mean?
10 equals C over 50 plus 0.
Which means C equals 500. So your Q is
So Q equals to 500 over 50 plus T.
and that is how the amount of salt is being measured here. Okay. And so now, how do we figure out how many pounds is there when the tank is filled? Yes, time for tank to fill is yeah, what's the number?
50 plus 14.
Okay, what equation do I have to solve so you get to it?
Oh, we found it.
Final volume to initial volume.
What's the volume here? How do we measure the volume in this problem? No, just tell me the formula, this specific problem. Not general formula, the specific formula for this problem. Volume.
100 plus 1 times C?
100 equals.
Is that what you want? Is that what you're asking?
No, I'm asking for the volume. How do you measure the current volume in this problem? 50 plus T.
Alright, there we go.
The guy right here, that's what this is, current volume.
Right. I was
What do we want that to be? We want it to be 100 because that's how many gallons is in the tank. How much time is that going to take?
50 minutes.
50 minutes, right? So if I want to know the amount when the tank is full, what do I need to find?
What the concentration is the time T equals 50?
Not concentration, amount. They ask for amount or concentration? The amount is what we want.
1.
So just find Q of T. Equals 500 over, if T is 50, it's supposed to be 100. So it's 5 pounds at the time it becomes full. Right, so if I have 10 pounds of salt in a tank, I'm pouring in fresh water at 2 gallons per minute, and the mixture is flowing out at 1 gallon per minute. By the time it fulls, I'll only have 5 pounds of salt left in the tank. I would have gotten rid of 5 pounds of salt. Any questions? So reading is the hardest part, right?
That's all I need.
Let's move on to the next one. I don't remember what final I took this one. Okay, problem 11 on our handout. I'll have to look up the final. It's not the same final, so this is from a different final. Spring 13, if I'm not mistaken, but don't quote me on that. Okay, a 200-gallon tank is half full of pure water. A salt solution with a concentration of 5 pounds per gallon is flowing into the tank at a rate of 4 gallons per minute, while the Wells mixed solution is flowing out at a rate of 2 gallons per minute. Find Q of T, the amount of salt in pounds in the tank at T time T minutes. Right, so they already told us what Q is, so we'll use their notation. Q is the amount of salt, which means Q prime is equal to C in R in. Now, eventually I expect you to be able to just write down the equation, but since we're just learning the first few times you do this problem, it's good to just write down the formula over and over and over until you remember. Yes?
Professor?
Yes.
Why do you use 500 divided by 100? The 500 is the initial concentration, because Q.
No, Q was this. The amount is given by this much.
C is.
Right. And then the time I know it was 50. Okay. All right, so like I said, the first few times you're practicing when you're doing your homework, write down this formula all the time so you internalize it. By the time you get to the final, you can write down this and not even think about it. Okay. What's the concentration in? This is the
5 pounds per gallon.
Right, a salt solution concentration of 5 pounds per gallon, right? It's pounds per gallon, so you know that's concentration. So whenever they say concentration, you're going to look for units that look like amount of substance per unit volume. 5 pounds per gallon is what's the guy that's there. What's the rate that it's coming in at? Right, it's flowing into the tank at 4 gallons per minute. That's the rate. So that's 4. Minus, this is Q, over, what do we have? The initial volume is
100. 100.
100.
Great.
Right? You have a 200-gallon tank, but it's only half full, right? So the initial volume is 100. Yeah, reading is the hardest part, I understand. Right? Now, the rate in was what?
4.
4. The rate out is?
Minus 2.
And so the rate out is 2. Right? So what do we have? Q prime is equal to 20 minus 2Q over 100 plus 2T.
You can simplify that. Yeah.
You can. Q prime is equal to 20 minus Q over 50 plus T. What kind of equation is that?
Separable.
It's not separable.
No, it's not.
Oh, it's
It's a first order linear equation.
First order linear equation. You're taking too long to see that. Okay, how do we solve a first order linear equation?
Magic.
Find the integrating factor. How do I find the integrating factor?
Take the coefficient of
E to the integral of P, what is the P here?
50 plus T.
It means I can write this in standard form. This is 1 over 50 plus T Q equals 20. This is like your P. This is like your G, right? Which means it's in the form of a first order linear. The integrating factor is E to the integral of the P, right? Which is 1 over 50 plus T. Which is which is
50 plus T.
50 plus t. So I'm going to go multiply this equation through by 50 plus t. What happens to the left side? What does it become? $50 plus t times q, derivative, right? Product rule. Over here, what do I have? I just have 20 times 50 plus t. Now what? Integrate both sides. So this means 50 plus t times q is equal to integral 50. 50t, integral t squared over 2 plus c. This means q is equal to 20 times 50t plus c squared over 2 plus c all over 50 plus t. You can sort of make that look nicer. How can we make that look nicer? And I don't like this fraction here.
Distribute the 20.
Distribute the 20. 20 times 50 is 1000 t plus 10t squared plus c all over 50 plus t. How do I find that c? I need the initial condition. What is the initial condition? What is the initial condition? Why would you think it's 0? Right, it says initially the tank has fresh water, right? It's half full of pure water, which means there is no salt in the tank in the beginning, which means the initial condition is 0. So now all I have to do is plug in 0 for q while plugging in 0 for t, and I would get c over 50, which means that c is actually 0, which means that my q is 1000 t plus 10t squared over 50 plus t. And that completes part A. Part B, find the concentration of salt in the tank when the tank overflows. How do we do that? Yeah?
We first have to find the time it takes for it to overflow.
All right, time for overflow is what?
And Q is equal to
50 plus t equals 200.
No.
V0.
What is the volume? 100 plus 2t.
100.
What do I want that to be? 200. Right? Be careful, when you reduce here, it doesn't change what the original volume function is. You can't use the 50 plus t, because you would in fact be using half the volume instead of the whole volume. Right, so now I just solve for t. What is t? T is again 50.
50 what?
Whatever units we're doing, which in minutes? 50 minutes, right? So, I mean, units are important, but we're not in physics class. You don't have to be like all anal about units. Right, so it's 50 minutes, okay? So now, how do I get to the concentration? Plug in 50 into Q. This would be 1000 times 50 plus 10 times 50 squared over 2 times 50, which I can cancel that. And then I can take 2 into 1000 goes 500. and 2 into this goes 5. So it's 505 times, what, 5 times 50. 500 plus 250. So this is 750. So, is that the answer? Right, that's the amount of salt in the tank. Concentration is amount over volume, which means to get the concentration, we need to divide that by the volume. Right, so for you physics heads, I can put here that this is minutes, this is actually pounds. Pounds, and so the concentration needs to be pounds per gallon. This means concentration at time of overflow equals 750 divided by what? 200 pounds per gallon. 5 into this goes 4, 5 into that goes 15. What?
Yeah, that's right.
And the last question on this was that Newton's law of cooling question, which we did. Do you guys think you're getting this? So it all comes down to reading the question properly, knowing when is it talking about concentration, when is it talking about amount, and knowing how to follow the units to get to the right thing. We'll end there, and 2.3 homework will be due next time, I guess. Oh, we don't have class on Monday.
Why?
It's President's Day. And there are no classes tomorrow either. So if you have Thursday classes, don't be like showing up.